Good morning everyone. Myself Mynavathi, Assistant Professor, Department of Mathematics from KSA College of Arts and Science for Women. My paper name is Complex Analysis. Now we will discuss about the Unit 1 and 2. First one is Cauchy's integral formula and applications. Now, introduction to Cauchy's integral formula. The following topics are discussed in Introduction to Cauchy's integral formula. First one is Fundamental theorem in complex analysis, related line integral to point value of analytic function, basic formula. For an analytic function f of z inside a simple closed contour C, then f of a is equal to 1 by 2 pi I integral over C f of z divided by z minus a into dz, where a is any point inside C. Next, index of a point with respect to a closed curve. The following topics are discussed in index of a point with respect to a closed curve. First one is definition. The winding number or the index of a curve. N of C comma a is equal to 1 by 2 pi I integral over C dz divided by z minus a into dz. Then the following properties are satisfied. First one is the integral valued, invariant under continuous deformation, 0 for points outside the curves. Then some examples are discussed in this topic. Next one, higher derivatives in Cauchy's formula. Extended formula for the nth derivative, that is extended formula in Cauchy's derivative. The formula value is f power n of a is equal to 1 by 2 pi I integral over C f of z divided by z minus a the whole power n plus 1 into dz. In this topic, we will discuss also applications in power series expansions, relationship to Taylor series, and basic some examples. Next one is removable singularity and Taylor's theorem. First we will discuss the definition of removable singularity, then Riemann theorem or removable singularity, then the Taylor series for analytic function f of z is equal to summation n equal to 0 to infinity f power n of a divided by n factorial into z minus a the whole power n. Then also radius of convergence and power series of representation. Next one is zeros and poles. The following topics are discussed in zeros and poles. First one is classification of zeros, then the types of poles, simple poles, multiple poles and essential singularity, Lorentz series expansions around poles and residue calculation method. The topics are discussed in zeros and poles. Next one is the local mapping and maximum principle. The following topics are discussed in the local mapping and maximum principle. The first one is local behavior of analytic functions, conformal mapping properties, maximum modulus principle, that is modulus f of x less than or equal to maximum of z belongs to C modulus f of z, and also discussed in boundary value problems and minimum modulus principles. Next one is chain cycles and homologies. The following topics are discussed in chain cycles and homologies. The first one is definition of chains in complex analysis, properties of cycles, homology theory basis, simple connectivity versus multiple connectivity, then some applications of Cauchy's theorem. Next one is general form of Cauchy's theorem. The statement of the general theorem, requirement of validity, domain conditions, functions properties, proof outline and keynotes, applications to multiple connection regions are discussed in the general form of Cauchy's theorem concept. Next one is residue theorem and argument principle. What is the residue theorem? The residue theorem statement is integral over C f of z dz is equal to 2 pi I summation residue of f of a comma x, and also discuss the argument principle, that is 1 by 2 pi I integral f dash of z divided by f of z into dz equal to n minus b, where n is a number of zeros and p is a number of poles, and also discussed some application in complex integration. Thank you.